So we're going to talk about kinetic energy and work and power and how they're all related. So we've talked about it before. Energy is the ability to do work. It's measured in joules, and the specific type of energy, kinetic energy, is the energy of motion. So it's due to the motion of the object, and the amount of energy will depend on the mass and the speed of the object. It's got a nice straightforward equation. Kinetic energy is 1/2 times the mass times the square of the velocity. You do have to watch out for order of operations and only square the velocity. Don't square that whole side of the equation. Be very careful. And kind of one of the ways to think about this, and hopefully it makes sense, is if you want to double the speed of a moving object, it's going to require 4 times the amount of energy because there's that squared relationship. We've said work is a change in kinetic energy. And so to find the work done in speeding up or slowing down, you just have to take whatever the final kinetic energy is and subtract from it the initial kinetic energy, and that will give you the amount of work required. So here's an example. How much work is done stopping a 1,000 kilogram car moving at a speed of 25 meters per second. And so we start off with work as a change in kinetic energy, and we're going to use the kinetic energy equation for work. Work is 1/2 m times the difference in the square of the velocity. So it's kind of been rearranged, and you can see that. So work is equal to that 1,000 kilograms times the difference between 25 meters per second squared and 0 meters per second squared. Once again, be very, very careful with the order of operations. And if you run through the math, you get 312,500 joules. And so what we talk about more often than that joules and energy is power. Power in watts, power in horsepower for cars. And power is the amount of work done or energy used in a given amount of time. So it's joules per second. In general, we measure it in watts. So joules per second are watts. And power is just the change in the energy divided by the time. And so here's an example for you, once again with the cars. How much power is required to drive a car that has a mass of 15 kilograms, 15 meters up a hill every second. So every second it's going to cover 15 meters. And so if we use the idea that power is work over time, we're going to go back a little bit and look at work as force times distance because that's the information we have in here. We don't have the information to use kinetic energy, but we do have the information for work as force times distance. If we have the other, it would work. So we have the force is going to be the weight of the car. So we take the mass of the car times the acceleration due to gravity, and that's at 1,500 kilograms times 9.8 meters per second squared, and multiply that by 15 meters, which is the distance it's going to move. And it's going to do that every second. And so that's going to take 220,500 watts to do that. And if you go through the calculation with horsepower, that ends up being about 300 horsepower. So just if you're a car person, that might help solidify that in your mind. Alrighty, bye-bye.